Hello everyone and welcome to today's webinar where we'll be talking about a little known theory in the education world. Now, cognitive load theory is well known in the academic world, but less so known by those in the real world. Teachers, teacher aides, trainers, other educational professionals. And I just want to go through some of the basics of what cognitive load theory is, how you can use it in your day-to-day practice, and how you can use it from year 1 right through to teaching year 12s who are looking to get into university or college, and those who are working in the adult education sector. Now, as with all of these theories, whether they're advanced ones, as I sort of class this one to be, they're actually not that hard. And I think if you're watching any videos or blogs and you don't quite understand what they're talking about, whether it's in the education sort of world or any other world, then there's a really good chance that that person that's trying to teach you it doesn't really know what they're talking about. I think there's a bit of a skill in being able to take something that's not super complicated, but something that sounds complicated, and being able to explain it in its very most simplest form. So cognitive load theory is no different in that particularly in the education world, there's a lot of jargon, there's a lot of terminology, a lot of terms and terminology that's come from research and different writers and programs and so forth over the last 100 years. And even today, and I've read probably hundreds of books on education, I still see new terms all the time. So it's kind of a never-ending thing, right? Now, but just quickly, this is a very simple concept to understand. Again, as with most concepts in the education sort of arena. Cognitive simply means, probably not technically correct, but I think of it to mean something to do with the mind, right? So anything to do with thinking is what cognitive is all about. Load is kind of like a weight or an impact, and it sort of implies that there is a limited amount of weight that can be applied to something. And theory is just an idea. It's just an idea. Sometimes it's been proven, sometimes it hasn't been proven. Sometimes when things have been proven, they're kind of been proven in a dodgy way. But either way, a theory simply means idea. So we've got some type of idea about the mind or about thinking and how it's limited in some way, or how it's limited in some way. It's quite difficult to explain it from that perspective. Now, that in mind, I just wanted to go through and show you a basic graphic. I use this in my book because I think it's a good way to explain this particular concept. Now, I would like you to think of these two boxes as representing the total amount of information, processes and so forth that your brain can do at any one time. And in fact, I'm going to redraw that. So this is your brain. Now that I think about it, I could have actually drawn something that kind of looked like a brain. And as you can see, there is a limited amount of things that can happen in your brain at any one time. A limited amount of, I guess you could say, cognitive power. Now, let's assume, no, we won't even do that there. Let's assume that there is a particular task that requires a student or a person to use their short-term memory. So this part here is memory. Now, usually short-term or working. So working memory means what you can hold in your brain at any one time so that you can go about completing a particular task. Okay, so let's assume that short-term memory of your total brain takes up, what's that? It's about 3/4 or something like that. So say about 70%. Now the problem with that is that it only leaves about 30% for other tasks. Now, as educators, this is the part that we're really interested in. There are some aspects that we want of a course or activity or a task or whatever that we want students to memorise. But we don't want them to spend 70% of their total brain power just doing basic rote memory, trying to remember a formula, trying to remember a fact or whatever, because we do know that short-term memory kind of just disappears really quickly. And when students use information in real tasks, these types of tasks, and I'll go through and show you what I mean by these tasks, when they use them in these types of tasks regularly, then they actually develop better memory and more extensive memory, and they can recall facts quicker and for longer periods of time after those learning activities have been finished and they've moved on to other things, when they're actually working with those facts and figures and bits of knowledge in an actual contextual or real sort of way, in a real world kind of way. Now this part here is kind of I always call it the problem solving. The problem solving part. So you can call it various different things, but this is where there's an application. So process, actual problem solving, system, etc. So these are all the different tasks that we really want students to be able to do. We don't want them to spend a huge amount of time just recalling facts and figures because you haven't really taught them anything then. They're just doing rote learning, right? So what we really want them to do is spend more time in this area where they're doing abstract thinking and they're linking concepts together, solving problems, doing all these different types of things. So creativity is another one. Creative tasks or creative thinking, I guess. So these are all the bits and pieces that students need a little bit of factual information to be able to do, but we would much prefer it if they spent more time here than just trying to recall basic bits of information. So I think I've spoken about that enough. And another little analogy that I use is talking about the load or the weight on brain power, on total brain power. You could think of this box as being like a truck, right? Or a train or whatever. It can only carry so much of a load. So in this sense, the same sort of analogy applies, that if you fill that truck up or that train up with all this basic memory type work, then there's very little room left for problem solving. And remembering that the precursor to be able to do any of these things is they need that foundational information. So I'll go through a couple of examples in a minute about how that sort of works. Now, that pen's not dark enough. What we would much prefer is not that. What we would much prefer is that students spend more time here, we'll just call that MEM, more time here, problem solving. So this is where they're really challenging their brain, they're learning new concepts, developing their understanding of concepts, using these bits of information that they've got to be creative and so on and so forth. So even better, is if we can reduce it down like that so that we're at about 10% or less, 90%. So that means we want students to be spending the great majority of their time doing these types of things, as opposed to just remembering basic facts. Now, let me give you an example of that one. So if you've got a simple Venn diagram and let's say that you've got, I don't know, males, females, employed, right? And you're doing this with, say, year 8s, and it's a simple, even year 6s or something, and there's a simple probability. What is the probability that it'll be female and employed, or male or employed, or whatever? And you might have a third one here. Now, a simple little formula, so that's just a simple little formula, or a simple, well, it is a formula, but also let's just not even use a formula. Let's just see if we can work it out, because we've got that many there, that many there, that many there, let's say that. A simple process there is just being able to add up know what the Venn diagram means, and be able to hone in specifically on the area that we're concentrating on or that the question asks for, and being to add up that total outside of that, and then to be able to do a simple divide type of thing. So that would be the first step in being able to understand that, and then being able to explain their answer. Of course, if they don't know what a Venn diagram is, they don't know what these represent, they're going to be spending a lot of time in this area trying to figure out what the actual process is. So that's the process there. And less time being able to not only come up with the answer, but then being able to explain their answer and what that answer actually means and the purpose of using Venn diagrams and so forth. I can give you an even better example of that, one that I use quite regularly in my other videos. Actually, I'll give you two examples. So one example that I've used, I think it's one-on-one instruction video that I did not long ago, and that was about the process part of that I was talking about how to divide really simple things into multi-step processes. Now, if you divide something into a process and to a series of steps, and not only teach students how to do that as a bit of a metacognitive skill, but also provide that information for them, then they're able to just follow that process, right? So if you're teaching students how to do a basic linear graph, again, another maths example because maths is usually the easiest, then the first step would be to draw that. The second step might be to draw that. The third step might be to do a title. That might be the first step, actually. The next step might be to do something of a title for that axis and a title for that axis. They might also do a caption down the bottom. They might also then enter their data, right? And then they might draw the trend line. And then there might be down here something of an interpretation, right? So there's 8 steps involved in that. Most of those steps, if you said to a student, draw a linear trend graph that shows, or draw a linear line that shows the trend of X, Y, Z, and include your interpretation, students are really going to struggle with that. Even at the higher ends of high school, they're really going to struggle with that. But if you can divide it down, at least initially, into a series of steps, then students will know to follow that process. 1, 2, 3, 4, 5. Now, if you don't provide that information there, the problem is they're going to spend most of their time working at this level here. So most of their brain power is taken up trying to figure out what to do, what they've forgotten to do, and what goes next, and do I do it this way, do I do it that way, and so on and so forth. If you provide that for them, whether that's on a piece of paper or something simple, so it's like line 1, line 2, line 1, yeah, so you draw line 1. Then next, you draw line 2, so you draw the x-axis, you draw the y-axis, then you add the caption. So it's only like one word in each of those. That quite clearly outlines the process to be able to do that. And even when you get to the interpretation bit, again, that's where they need to do that deliberate practice and repetitive practice to be able to learn how to do that in different ways. But basically, you're just comparing that to that, right? Normally across the bottom, you have time. I think almost always you have time. So that's just a bit of that. Again, that's just a fact that they have to remember. And generally across here, you'll have your some type of measurement or some type of scale. So let's say that is, I don't know, weight. No, let's call that strength. Yeah, so strength. So over time, the more time you go to the gym, the stronger you're going to get. So boom, there's your graph. And there's only a few other different ways you could do that anyway, right? So you could go that way, you could go that way. You could have one where it doesn't really go anywhere and it kind of goes like that. Again, that's not linear. So that might be the next step that we're talking about, or another, not that we're talking about it, that might be the next step in the sequence of learning about different graphs or whatever. But point is, you've outlined something of a framework, something of a process, something of a system for them to go about figuring out how to do that. And you've reduced the working memory required so that they can spend more time here, more time problem solving these types of things. And I'll give you another example. And that is with, if you're working with older kids, so you can see how that applies to younger kids. That's, year 4 maths. That's maybe a bit older than year 4. So you can see how that applies to, say, the second half of primary school and onwards. Now, you've also got, if you're working in, say, year 11 and 12s, or you're working with students who are sitting exams or tests or whatever, one thing I used to always do, if they have a piece of paper, well, they'll always have a piece of paper as they're going through an activity, even if it's not a test or exam, is getting them to just jot down little bits of factoids in their own words, sort of up the top there on that piece of paper or down the bottom or on a blank piece of paper. It's kind of like a metacognitive skill. It's like a learning skill that you're teaching them so that they can then apply that to every single subject. So you might either provide that information to them by putting it on the board, or you may give them a worksheet, or a part of that worksheet, it's actually got it written there. It might be a little bit of a cheat sheet or something. You might do that as a model and then as a worked example / model on the board, and then just leave it up there for the entire lesson. You can just write it nicely in the top corner or whatever so students can refer back to it. And as we know that when you apply stuff in the real world in a context that makes sense, so in this area here by using these, or by doing sort of these types of tasks here, then students actually apply the bits of knowledge that they need to know to be able to do that, the foundational knowledge. They actually apply that to long-term memory, and it becomes also automated so that it no longer becomes a memory task, it's just recalled like that. So that way, over a period of a few lessons, if you're taking advantage of cognitive load theory, students won't need to use the short-term memory part of their brain or the cheat sheet or wherever you've put it on the board or whatnot, because it'll then just become almost 100% problem solving, assuming they're not moving on to ever more challenging activities. Now, at one point I was teaching year 11 and 12 Indonesian, and what I used to get them to do is to go into their exam, and these are exams to get into university and things, so they needed to get a good score. You know there's going to be some type of letter. They have to write a letter to a friend or a principal or a job application or whatever. You know there's going to be something like that in there. So the first thing I used to get them to do is blank piece of paper as they come in, or on the back of the exam or whatever, and write out 10 or 15 different phrases that they'd memorised that they can then insert as a basis for being able to write and construct that letter. Then all they have to do is effectively fill in the gaps, the type of phrases that you could use in all different types of letters, or regardless of what the piece of writing is, which is always a letter. And that's, on the other hand, I am sending this letter in order to, please accept this letter as compared to X rather than, or something like that. So you've got all these little phrases. Thank you for taking the time to blah, 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 listen to my concerns or listen to my ideas. On the other hand, I think I already mentioned that one. I can't even remember them now. I used to have a list of 50 or 60 of them, and students should learn how to write that in that second language, and then they could just go through and apply 20 of them in a 200-word, say 300-word letter. More than 50% of that would be just using these different sentence starters and ways of just phrasing sentences that were near perfect, and it almost guaranteed a decent mark for that particular aspect. So it's just a different way of reducing that memory load down. And then that way they're still using their memory a little bit. They do have dictionaries in that case, but they spend more time here trying to do the creative stuff. So that's how that might apply in a memory task, in those high school years, or even if you're dealing with adults and they're doing something like, I don't know, learning how to fly a plane, then you don't want someone who's learning how to fly a plane spending much time here. You want them spending 90% of their time, probably 99% of their time, actually doing these types of things. So applying their knowledge without thinking, what should I do? The engine's on fire. Now I know there's something I need to do when the engine's on fire. What was that? Trying to recall. No, you don't want them doing that. You want that information to be available, or you want it to be automated. So they've gone through and done it 100 times so that it's automated. You want them to spend their time here solving that problem. So anyway, that's the basics of cognitive load theory. I've given you 3 or 4 examples there, I think. Don't be afraid to use it, whether you're teaching adults or whether you're teaching little kids or whatever. It's applicable through right through all the different age groups and levels of ability and different subjects and so on and so forth. And again, it's a very, very simple process. It does help with long-term memory by effectively giving students the answers, I guess, but the basic foundational bits of knowledge that they need to know and steps and so forth. It means that they can spend more time on the things, using brain power for the things that we want them to spend brain power on. And in fact, what actually happens is that in the end, they learn more knowledge and more facts and processes and so forth than if they had been asked to memorize them in the first place without having that reference. So you can apply that in activities and lessons and in courses and so forth, but you can also provide students with that strategy in terms of it being a metacognitive skill of sorts, so that they can then go about using cognitive load theory, even if you don't tell them you can tell them it's called that, but even if you don't tell them the name of that task or the name of that strategy, but you can teach them how to go about doing those sort of mnemonic or memory techniques so that they can then spend more time on this the types of activities that will get them a better score. Not that it's only used for exams, it is used throughout all educational settings when we're trying to teach kids to learn new concepts, learn and apply new concepts. So that's cognitive load theory and my take on it. I hope that helps, and good luck in applying cognitive load theory out there in the real world.